Hello class, welcome to this video. So this is going to be part 2 of the midterm review. So we're going to cover the next set of questions for the review. So for 21, which sequence of transformations will result in an image that is not congruent to triangle ABC graphed on the coordinate grid below? Select all that apply. So we have our pre-image here and we want to undergo a sequence of transformations. A sequence is sort of like a series of transformations, so it's one after another, so it's more than one transformation. And we want the transformation to result in something that is not congruent, which means that we want a transformation that is not a rigid motion transformation, something that is not a congruence transformation. So for example, if you're doing a translation does not change the shape of the figure, and so that's a congruence transformation. So is a reflection. A reflection does not change the shape of the image. It doesn't change the length measures or the angle measures. So it's not going to be this one because it's going to lead to a figure that is congruent, and we are looking for something that is not congruent. B, a reflection across the y-axis. Again, a reflection indicates that it's going to be congruent if we did that, and so is a rotation. A dilation by a scale factor of 2 about the origin, followed by a translation 3 units down. Now, if we do a dilation by a scale factor of 2, you're essentially making this twice as large. So you're increasing this by twice as much, and that changes the length measure in the shape. And so that's what we want, because that will no longer be congruent if we do a dilation. So this is the answer. Number 22, triangle ABC is rotated 155 degrees about the origin, translated up 2 units, and reflected across the line y equals x to yield a prime, b prime, c prime. Are the two triangles congruent? Why or why not? So if we're doing a rotation, remember a rotation does not change the rotation preserves the length and angles of the shape. So in other words, it doesn't really change the shape, it just rotates it. And translating up 2 units and reflecting does not change the shape as well. It just changes the orientation and so on. So these two triangles are going to be congruent because the distance is preserved. So yes, the distance is preserved in these transformations. Figure 1 is reflected about the x-axis and then translated 4 units left. Which figure results? So if we're taking this figure 1 and we're reflecting it about the x-axis, that means we're reflecting it about this axis. Well, then each of these points is going to be reflected over the same distance. So it's going to be 1, 2, 1, 2. This is 1, 2, 3, 4 distances, 4 units across. So we'll do 4 units across here and so on. And this right here is basically all the way on this side, here and here. And so we get a shape that looks like this. So that's a reflection about the x, and then we're translating it 4 units to the left. So 1, 2, 3, 4, and so on. And if we did that, it'll look like we get something like figure A. It is known that a series of rotations, translations, and reflections superimposes sides A, B, and C of quadrilateral X onto 3 sides of quadrilateral Y. Which is true about Z, the length of the fourth side of the quadrilateral Y? So it says that, we have this quadrilateral here, and we're doing rotations, translations, and reflections, which we know do not change the shape. It's just transforming it without changing the shape at all. So that means if you're doing these rigid motions, or what we call congruence transformations, the lengths are preserved, and therefore the length of the fourth side should not change. And in this case, this fourth side, which we'll call Z, should not change and should remain at a value of 6. The length measure, that is. Given the figure below, which one piece of evidence would allow the triangles to be proven congruent? So we know that we have a line L here, and if I were to reflect this across line L, then I would get the shape that I see here. And remember that a reflection is a form of congruence transformation, which means that all the lengths and angles are preserved, and so therefore the resulting figure, the image in this case, this is the image, will be conserved, the measures and everything. So the image is going to be the same as the pre-image. Is going to be congruent as far as the measures are concerned. So in this case, the only piece of evidence we need for this to be for us to show that this is congruent is that we have a reflection taking place, and that is by definition, a reflection is a congruence transformation. Now let's take a look at the other choices to see if they make sense. So if we said xy was equal to 6 right here, that only tells us that angle measure. That doesn't tell us anything else in the shape. So we can't tell based off of just the one side. Neither can we tell if we just know that this is 86. That really doesn't help us with the other angle measures. So you can see the other choices really only give us one piece of the information, and the only way that we can get all of the information is to know that there's some kind of transformation taking place. All right, the next question, triangle ABC is transformed to form triangle XYZ. So there's some kind of transformation, maybe a kind of a reflection or translation or something. So it says if AC is equal to BC and the perimeter of the triangle is 37 inches, what are the lengths of the sides of the triangle that would make the two triangles congruent? So they mentioned that AC is equal to BC, and so that means, so we're going to indicate those with those tick marks there. And so it looks like it's at least an isosceles triangle from what we can see. Now it does say the perimeter of ABC is 37 inches. And so that means since these two sides are the same, I'm just going to call it X. And we know that the perimeter is when you add the lengths of the sides, and so we're going to add all of these sides here, and we know that that perimeter of that triangle has to be 37. And so if we combine like terms, we have 2x plus 13 equals 37. Go ahead and subtract 13 on both sides, and we'll get 24. And so both of those sides have to be 12. So I'm going to go ahead and label those 12 now. All right, so now what are the lengths of the sides of the other triangle such that they're congruent? Well, since they're congruent, that means we can use this transformation, or we can use this relationship to help us. So we know that AB is congruent to XY, and so AB here has to be congruent to this side. So this side has to be 13. So now we know that XY is 13. We can also tell from this congruence relation that BC is congruent to YZ, just based off of that order. So that means the other two sides have to be 12. All right, so XY is 13, YZ is 12, and XZ is 12. So we have here, looks like this guy. This is the answer. All right, the next question. Triangle LMO is congruent to triangle PQR, according to the figure given. If angle L is 62 degrees and angle M is 57 degrees, what is the measure of angle R in degrees? Well, we want to figure out this angle. Now, we know from the relation here that angle O has to be congruent to angle R, because of that congruence relation there. And so if we find this angle, then we know what angle R is. Angle O is pretty easy to find, however, because by the triangle angle sum theorem, the angles in the interior angles of a triangle add up to 180 degrees. So let's call this X, and we know that those angles have to add up to 180. So if we add these, combine your like terms, you have 119. We'll subtract 119 on both sides. And so the missing angle is 61 degrees, which has to be the same as angle R. All right, so number 28, if triangle TRI is congruent to triangle ANG, which of the following congruent statements are true? So again, this is similar to what we've been doing in the past couple of questions. We know from this that TR is congruent to AN, so this is true. We know that TI is congruent to AG, just looking at those. So this is true. RI is congruent to NG. TI we said was congruent to AG and not NA, so it's not this one. We know that angle T is congruent to angle A, angle R is congruent to angle N, angle I is congruent to angle G, and that's all we know. Consider triangle ABC that has been transformed through rigid motions and its image is compared to triangle XYZ. Determine if the given information is sufficient to draw the provided conclusions. Okay, so we're going to need to draw just draw the triangle here. So let's say we have triangle ABC. And let's use the information they gave us. They gave us, so we're given, and it says that there's another triangle that is supposedly we had to conclude, we have to see if it's going to be congruent or not. So they said that we're given that angle A is congruent to angle X. We're also given that AB is congruent to XY, and BC is congruent to YZ. Okay, so is this enough information to conclude that these two triangles are congruent? Well, if you look at this, we have side, side, angle, side, side, angle. So we can't prove that two triangles are congruent to each other by SSA. SSA is not one of the congruence criteria by which we can determine if the two triangles are congruent. The only triangle congruence criterion that we can use to conclude that two triangles are congruent is angle, angle, side, angle, side, angle, side, angle, side, or side, side, side. So if we know two angles in the side, if we know two angles in the included side, if we know two sides and the included angle in between, or if we know three sides, then we can conclude that the two triangles are congruent. So here we do not have enough information, so we're going to say that's false. Okay, so again, using the same diagram, and I'll re-illustrate it here. Angle A is congruent to angle X. Angle B is congruent to angle Y. And BC is congruent to YZ. Is there enough information to conclude that these two triangles are congruent? Well, we have an angle, and a side, an angle, and a side, which is AAS. That's actually one of the congruence criterion that we can use to conclude that the two triangles are congruent. So this is good. So this is true. Angle A is congruent to angle X for this problem. AB is congruent to XY, and BC is congruent to YZ. Now this looks remarkably, let's see, AB, this is actually the same problem as what we had earlier. So we said earlier that this was SSA, and therefore we cannot prove congruence here. So this looks very similar. In fact, it's probably the same question. So that one's going to be a false. All right, number 30. For two isosceles right triangles, what is not enough information to prove congruence? So the lengths of all sides of each triangle. Let's go ahead and draw each two isosceles right triangles. So we have a right triangle here, and it's isosceles, so these two legs are the same. And these two legs are the same. All right, so we got two isosceles right triangles. What do we need to know to show that they're congruent? Now, if we knew the lengths of all the sides of the triangle, then of course we know that the two triangles will be congruent. So if I knew that this was for example, a 3, 3, square root of 10 triangle, or square root of 18 triangle, 3, 3, square root of 18, so on, then obviously the two triangles are going to be congruent. So this is not going to be the answer because we need something that is not enough information. The lengths of the hypotenuses for each triangle. So if we know the hypotenuse of the triangle, so if I knew, for example, that this was the square root of 18, then we can show that these two triangles are congruent. And that is because these two triangles, these two sides are the same, and therefore, and we know that since this is a right triangle, we can use Pythagorean theorem to get the other two sides. And if you did, you would get that each of the sides are equal to, for example, 3. If we used the Pythagorean theorem. And if this is square root of 18, using the Pythagorean theorem, these would also be 3. And therefore, you would be able to show that these two triangles are congruent. So if you knew the hypotenuses, then you would be able to establish, yes, they are congruent. So that means it can't be this one. The lengths of a pair of corresponding legs. So if we knew, for example, that this was 3 and this was 3, well then, because it's an isosceles triangle by definition, this has to be 3 as well. And because those are the same, that means the third side has to be the same, because if you did the Pythagorean theorem, you would get, for example, square root of 18. Square root of 18. And just to verify that, so if you were to do 3 squared plus 3 squared, you would get 9 plus 9, which is c squared, and then the square root of 18 will give you the third side. So it can't be this one. So let's look at the last answer to see why it would be the correct answer. The measures of the non-right angles in each triangle. So if we knew all the angles in the triangle, so if we knew these angles, well then this would be, in this case, this would be an angle, 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 angle. And that would not be enough information to determine that they're congruent. Remember that the only 4 congruence criterion that we can use to establish that two triangles are congruent are these, and which does not include angle, angle, angle. So this has to be the right response. All right, number 31, given XZ is the perpendicular bisector of WY, prove that triangle WXZ is congruent to triangle YXZ. So let's go ahead and draw this. So we have a triangle. We have a couple of triangles here. So we have W. Now it says ZX is a perpendicular bisector of WY. So that means WY, if this is WY, then ZX is cutting it. Bisector means you cut into 2. So cutting into 2 equal pieces. Perpendicular means 90 degrees. So that means ZX is cutting this at this angle. And so it looks like this, if this is W, this is going to be Y. And so X has to be here. And so this is Z. So it's basically cutting it this way. So we got triangle WXZ, and then we have this other triangle XYZ. And so this is a 90 degree angle, this is a 90 degree angle, this is cut in half because it's a bisector, and so those two have to be the same. Now, how can we show that these two triangles are the same? Well, it's pretty straightforward because you know you have a side, you have an angle, you have a side and an angle. And notice that these two triangles share this side in the middle. And so obviously if they share that side in the middle, then that side is congruent to itself. That's known as the reflexive property, where a side is congruent to itself. So in this case, XZ is congruent to XZ. Anything is congruent to itself. And so we have side, angle, side, side, angle, side. So we can establish that these two triangles are congruent by SAS. All right, number 32, for two triangles with identical orientation as given below, what rigid motion is necessary for SAS congruence to be shown? So for example, if you knew that if you wanted to show that these were the same, and this angle between them is the same, well, that's pretty straightforward. All you have to do is, since they're in the identical orientation, all you have to do is just slide this over and see that they overlap. So all you got to do is a translation. Select the statements that contradict each other. So angle 1 and angle 2 are supplementary angles. Remember that supplementary angles add up to 180 degrees. So let's write this statement. So this means that measure of angle 1 plus the measure of angle 2 is equal to 180. Now they said in B that angle 1 is 110. So if angle 1 is 110, then that means that this is going to be 70, right? So 70 plus 110 is 180. All right, no contradiction so far. C, it says here that angle 1 plus angle 2 plus angle 3 is 180, and angle 3 cannot be 0. Well, we just said that these two angles have to add up to 180. And so if we have something else added to it, then that's going to contradict what number 1 says. And so therefore, these are the two statements that contradict. If n is parallel to m, find the measures of angle 1 and angle 2. Okay, so we know that these two lines are parallel, and we'll indicate this with an arrow. So now if we know that this is 20 degrees, then because these are vertical angles, this is going to be 20 degrees as well. Remember, vertical angles is an angle pair where you have two lines crossing, and then you have two angles opposite of each other like this. So those two are congruent by vertical angles. And since we know that this is 20, then we know that this is 20 degrees as well, because these, if this is a transversal and these are your parallel lines, then these two angles, this 20 degree angle and angle 2 are alternate interior angles. And so alternate interior angles are congruent. All right, similarly, if we look at 60 degrees here, then this has to be 60 because of vertical angles. And if we consider this transversal, then this 60 degree angle and this angle 4 are alternate interior angles, and they have to be equal. In any case, we have angle 1 and angle 2 already, so we can go ahead and add them together. So we have 60 degrees here plus 20 degrees. So our answer is going to be 80 degrees. All right, what is the value of x according to the figure below? There are two variables here, so we're probably going to have to set up a system of equations of sorts. So we know that because this angle and this angle are next to each other like this, and they form a straight line, that this is what we call a linear pair. So they add up to a half circle, which you can kind of see here, and a half circle is 180, or a straight angle. So we know that these two angles add up to 180. They're supplementary. So that's one of our equations, but as you can see, we can't really do anything with this equation because we have two variables. So we're going to need another equation. However, we also know that because of vertical angles, this and this angle, those angles have to be the same due to vertical angles. So we have this is also equal to 3x plus 7. And we also know that this angle and this angle have to add up to 90 degrees. And the reason being is that this is 90 degrees, and so all of this has to add up to 180. But since this is already 90 degrees, then 90 plus 90 is 180. And so therefore, this 3x plus 7 and y has to add up to a total of 90. So we have here 3x plus 7 plus y equals 90. Notice that these two things match. So we can do some kind of substitution here. So what I'm going to do is I'm going to get rid of this y. I'm going to solve for this and then substitute that here. So let's go ahead and solve for this by getting rid of this y. We'll subtract y on both sides. And so we get the 3x plus 7, and I'll box it, is equal to 90 minus y. Now I'm going to substitute this in for 3x plus 7 here. So this will get replaced. So we'll bring this down. We have 5y plus 10. I can replace what's in the box with what's circled here, 90 minus y. And so now that got replaced. And this is equal to 180. Now we have an equation with only one variable. We can solve this. So we have 5y minus y is 4y. 10 plus 90 is 100. Let's subtract 100 on both sides. So this is equal to 80. So divide by 4, and so we get that y is equal to 20. So if we know that y is 20, well then we can plug that in here. And we know that this is 5 times 20 plus 10. It's going to be 100 plus 10. So this is 110 degrees. Which means that this angle here has to be 70 degrees because 110 plus 70 is 180. And so we can solve this equation here. So we'll subtract 7 on both sides. Then divide by 3. 3 goes into 63 nicely, so you'll get 21. So x is equal to 21. All right, drag the correct statements and reasons to complete the proof. So there isn't a picture of the proof here, but we can do the proof for this problem and use these available responses. So we're given that angles 1 and 2 equal 90 degrees, so they add up to a right angle. So that means they're complementary. Angles 2 and 3 are also complementary, and they add up to 90. All right, so if we're given those two things, how can we prove that angle 1 is congruent to angle 3? So to show this, we'll go ahead and do a 2-column proof. So we have our statement and our reasons. Remember that the first statement is always going to be what's given. Okay, so what's given is that these two angles add up to 90. And those two angles as well. So the reason for that is that it's given. Now let's go ahead and move on to the next step. Now because these are both equal to 90 degrees, then that means that they must be equal to each other. And so we're going to do a substitution. Since we know that 90 is equal to 90, because, 90 is equal to itself, right? Then that means angle 1, so we can do a substitution and replace this with angle 1 plus angle 2. And then similarly, we can do this. We can replace that 90 with angle 3 plus angle 4. So this could be referred to as a transitive property or a substitution property. Now, in this case, we don't have a transitive property, so we'll use substitution. And we'll just say that we substituted in for these numbers. And so now what we have is we have that angle 1 and angle 2 is equal to angle 3 plus angle 4. And we'll employ the substitution property for this. And technically, I'm partial to using the transitive property for this, but you can also think of it as a substitution if you think about it this way. All right, so the next step, what we want to do is, since we know that they're equal to each other, we have this equation. We can also say that, and I got the numbers here incorrect. So this is angle 2 and angle 3. So let me change those numbers real quick. Apologize for that. And so now notice if we just examine that equation for a second, notice that we have two things that are the same. So if we were to subtract those on both sides, then they would cancel. And that would leave us with those two are equal to each other. And so what we're going to do is we're going to use this property here. We're going to subtract angle 2 on both sides, and that's known as the subtraction property. So the subtraction property of equality. So we're going to use that property, and in doing that property, we can conclude that measure of angle 1 is equal to measure of angle 3. Now, because these two angles are equal, that means they have to be congruent. And that just makes sense. If they're equal, then they're congruent. And that's by the definition of congruence. All right, and the proof is completed because we've shown that angle 1 is congruent to angle 3. All right, which statement correctly relates angle B and angle D? Using the figure below. All right, so we're interested in angle B and angle D. So we're interested in comparing those. Okay, so we know that these two sides are congruent, and these two sides are congruent. And we know that this is 45 degrees, but we don't know what this angle is. So we can't really show that they're congruent. And in fact, if you look at the opposite side here, this is 13, this is 11. That indicates that these two triangles are not congruent. We're going to use a theorem known as the Hinge Theorem. The Hinge Theorem essentially helps us compare two triangles that have two pairs of corresponding congruent sides, just like this. And Hinge Theorem states that, well, if you have an included angle between these, you can compare those included angles to each other, or you can do the opposite and compare the opposite sides to those angles. So we have this angle here, which I'll just put it right here, 4x plus 5. You go opposite of that, and we can compare those two sides directly. So we can compare 13 and 11. And so what we're doing is the converse of the Hinge theorem. So obviously 13 is larger than 11, which means that the angle opposite of it, which is 45 degrees, is going to be larger than 4x plus 5. So we know from this theorem that 4x plus 5 is smaller than 45 degrees, or 45 is larger. Okay, so let's, to make this a little easier to comprehend, I'm going to just ignore this triangle for a second because we don't really need it for this diagram. So let's call this angle E. And we'll say that angle E, the measure of angle E, is less than the measure of angle A. Just for the purposes of this exercise. Okay, so now we know that angle E is smaller because the opposite side is smaller. And so, but we want to compare B and D, right? All right, so we know that these two angles are congruent, and that's because they're vertical angles. So far we have 45 degrees, we have some kind of angle that's congruent to this, and we have this unknown. Remember that in a triangle, all the angles add up to 180 degrees. So for this triangle here, let's go ahead and write the triangle angle sum theorem. Let's go ahead and add the angles to 180. We have angle A, which we know is 45 degrees, plus angle B, which we do not know, and angle C, which we also do not know. I'll just call this angle C. And that has to add to 180. Now let's do the triangle angle sum theorem for this triangle. We know that the angles add up to 180 there as well. So we have the measure of angle C. We have this angle D, which we don't know. And we have this angle E, which we also don't know. Now, if we examine this for a second, we know that angle C is equal for both of them. So that really doesn't contribute anything to this conversation. We know that angle A is 45. So what we want to do is compare these two. We know that angle E is smaller than angle A. So for example, maybe 40 degrees, just as a substitution, just for the purposes of this example here. And so let's make up some numbers here. Let's say that angle C is 30, just for our argument's sake. It doesn't really matter, it's the same number. But let's say it's 30. So we have 45 plus angle B plus 30 is 180. If we were to subtract that 30 over to the other side, that gives us 150. So let's go ahead and do that now, just to simplify things. All right, we'll do this for the red equation as well. So let's substitute in 40 degrees. And again, we had the 30 and the 180. Let's move the 30 over and make this 150. All right, now let's focus on this part. So they're both equal to 150, and this is smaller than that. So if this is smaller than the top, that means this has to be larger than B. So our argument was that because angle E is less than angle A, this implies that angle D is larger than angle B. And so we're able to show that the measure of angle D is bigger than the measure of angle B. In other words, angle B is smaller. So there's a lot of argument going on there. So we ended up using the Hinge Theorem and vertical angles along with the triangle angle sum theorem to show that the relationship between those two angles. All right, for number 38, what is the perimeter of triangle XYZ? Now, there's a lot more going on to this problem than meets the eye. So this is a problem that involves special centers of triangles. Now, there are a few special centers of triangles that we discussed. And the way I remember these is by using the following, I guess you can say, mnemonic. And the mnemonic goes like this. So my cousin always owes Anna banana ice cream, probably before Christmas. So this is just a mnemonic to help you remember which special segment goes with which special center in a triangle. So this my is the median. Remember, the median of a triangle, it connects the midpoint of one side to the vertex on the opposite side. And that's the median. So basically it cuts this in half, this opposite side in half. And the median, the special center for the median, if you combine multiple medians together, that special center in the middle is called the centroid. All right, similarly, if we did this one's the altitude, and this is related to the orthocenter. Now the altitude is when you form a right angle from one vertex to the opposite side. And where they cross is known as the orthocenter. Now, angle AB stands for angle bisector. And this stands for incenter. Now, angle bisector is when you cut an angle in half. And when you do this, and you cut the angles in half, then where those two lines meet, or those three lines meet, is known as the incenter. And then lastly, we have perpendicular bisector. And where those lines meet is referred to as a circumcenter. Now, perpendicular bisector means that you cut each side in half at a 90-degree angle. And so if you did that, then eventually those three lines will meet, and where they meet is the circumcenter. Okay, now that I established the overview of the four centers and the four special segments, how does this relate to this problem? Well, this problem is an angle bisector in-center problem. So an in-center is, like we mentioned, is the intersection of angle bisectors. So let's draw those angle bisectors here. So this angle bisector and this angle bisector. And so that means that these angles are congruent. They're not congruent to each other, like separately. They're congruent to each half, but they may be different to each other. Okay, so this cuts this in half. So it could be like, for example, 30 on each side. This could be like 15 on each side and so on. All right, and where they meet is the in-center. So this is my in-center. Now the in-center has a very cool property that the distance from the in-center to each of the sides on the triangle is the same, and therefore you can draw what we call a inscribed circle. And that's what this is. All right, so let's go ahead and solve the problem then. So now that we know those special properties, now that's going to help us because we're going to be able to deduce something important. All right, so we want to figure out the perimeter of this shape. So if we know that this is 7, let's focus on this triangle for a second. We know that this is a right angle because this is a right angle. So we got a right triangle here. We also know that this is a right triangle. Now, are these two, the yellow and the green triangles, are they congruent? And the answer is yes. And that's because you have these two sides are congruent because they're congruent. They share the same side. We know that these two purple angles are congruent to each other. And we also know that these two angles are congruent because they're right angles. And so by in this case, we're here by angle, side, these two triangles are congruent. Remember, angle, side can be used to show that two triangles are congruent. All right, so then that's important because if those two triangles are congruent, then that means that if this side were equal to 7, this side is 7. Similarly, if this side is 6, this side is equal to 6 because those two triangles are congruent by AAS. If this is 9, then this is 9. So all of these steps just to conclude that those are the same. And now we can find the perimeter. 9 plus 7 is 16. 9 plus 6 is 15. 6 plus 7 is 13. We can add these three sides to get the perimeter of our triangle. So 15 plus 13 is 28. 28 plus 16 is 44. And there's our perimeter. So there's a lot of concepts that are going on that meets the eye that you would have to understand that we have gone over throughout the course if you have taken this course. A triangle has vertices at -4, 0, 2, 8, and 8, 0. Complete the table. We're going to finish off with this problem because this problem, there's a lot going on in this problem, and there's a lot of steps that are involved. So let's go ahead and find the centroid first. We want to find out the x and y coordinates of the centroid. We know that the y coordinate is 2 2/3, but I'm going to show you how to find both coordinates. All right, so let's go and draw our triangle. So this is our triangle. And notice, even though it's not drawn very well here, these two sides are actually the same. And we can tell that because this is going up 1, 2, 3, 4, 5, 6, 7, 8. It's going up 8. And it's going over 1, 2, 3, 4, 5, 6. And it's going over 6 here. And similarly, this is going over 6 and down 8. And so those two sides are actually congruent. They're the same distance. All right, so that means we're dealing with an isosceles triangle. So let's go ahead and show you, let's go ahead and do the centroid. Remember that the centroid, using our mnemonic here, my cousin always owes Anna banana ice cream, probably before Christmas. So we're dealing with the centroid, so we're dealing with the median. So let's draw the median. The median is drawn from a vertex to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. Now this one's pretty easy to tell. What's the midpoint of this one? The midpoint of this one is pretty easy. If we know that this is -4, this is 8, well then we average 8 and 4 together. So 8 plus -4 divided by 2. 8 plus -4 is 4, 4 divided by 2 is 2. So the midpoint is right here. Okay, so where these points cross is going to be my centroid. All right, so let's use this line as my median because that's a really easy line. The equation of that line is x equals 2. And that's because it's a completely vertical line crossing the x value of 2. Let's use this point right here, or this other purple median. And what we want to do is figure out where they cross. Where they cross is going to be my solution for the centroid. Now the coordinates, so these coordinates here we need to find. So what are those coordinates? Well, we know that to find the midpoint, we know the coordinates here. This is -4, 0. This is 2, 8. So we can find the midpoint here by averaging these coordinates. So let's go and add those together. So -4 plus 2 divided by 2 and 0 plus 8 divided by 2. That'll give me the average or halfway point. So we have -2 divided by 2 is -1. 0 plus 8 is 4, or 8 divided by 2 is 4. Okay, so we know the coordinates here are -1, 4. All right. We need to find out the equation of this black line. It's black now. So if we want to figure out the equation of that line, we need to figure out two things. We need to find the slope and pick a point on that line. So let's do the slope first. We got rise over run. How much does it rise? Well, it rises 4. How much does it run? Well, it runs about 9. So the slope is rise over run. So it goes down 4 over 9. So it's -4 over 9. So there's my slope. Let's pick this as a point on that line, 8, 0, because 8, 0 is an easy point. All right, so we have y equals mx plus b is the equation of that line. Plug in the slope. Let's plug in our x and y here. X is 8, y is 0. Okay, so we got some kind of decimal here. That's okay. So we have -32 over 9. To multiply these fractions, just multiply straight across. If we move this, we're going to add 32 over 9 on both sides. So we know what b is. b is 32 over 9. Okay, so we have our equation because we can plug it in here. And this is going to be 32 over 9. All right, so we got that equation. What next? So we got this equation is that, and we want to use x equals 2 with it, right? So all we got to do is plug in 2 in here, and that will tell us where they cross. That's what we want to do. So let's plug in 2 into that equation. Y equals -4 ninths times 2 plus 32 over 9. And that will tell us what we need to know for our coordinates. So we have here -8 over 9 plus 32 over 9. 32 minus 8 is 24. So this is going to be 24 over 9. All right, so we know y and we know x. X is equal to 2, y equals 24 over 9. 24 over 9, 9 goes into 24 2 times. 9 times 2 is 18. We got a remainder of 6. And this is the same thing as 2 2/3, right? It's exactly what we found here. And the x value is 2. Now, I know that's a lot to find the centroid. Here's a shortcut to find the centroid as well. The centroid can be calculated without using this method by using the following formula. You can calculate the centroid by taking the average of all the x coordinates and all the y coordinates. So this divided by 3, because you got 3 numbers, and average the y coordinates as well. And notice if we did that, we get -2 plus 8 is 6, 0 plus 8 is 8, and we get 6 divided by 3 is 2, 8 over 3 is 2 2/3. So pretty cool, right? So that's how we can do the centroid quickly, just by doing the average. Now the other coordinates, as far as I'm aware, there's probably not an easy way to get those other than the method that I'm showing you. Okay, so I'm going to show you the reason why I showed you how to do the centroid method here is because this is how we're going to do it for the rest of them. There is no clear-cut formula, as far as I'm aware, to find the other ones. Okay, so we're going to next find the circumcenter. And actually, we'll continue this in the next part. So thank you for this video, guys. Thank you for watching this video. I hope you learned something. I will continue the rest of this question and the last 20 problems in the next one.